Welcome to Unit 1 of Foundations of Algebra. We'll start our conversation with Chapter 1, Section 1, and we will build from there. We're going to start our conversation with some definitions so that when I use some of this language, you know what I'm talking about. A rational number, that's any number that can be expressed as a fraction, such as 3/4 would be an example. That's a fraction. 2/9, that's a fraction. The number 1 is a fraction. You could think of it as 1/1. That works. Even the number 2.57, a terminating decimal, can be written as a fraction. And a repeating decimal, like 0.4444 and on and on and on. Repeating decimals can also be written as fractions. Everything else is an irrational number. That is, an irrational number is a number that cannot be expressed as a fraction. A go-to example for this would be pi. A lot of you have heard of pi before, that never-ending and non-repeating decimal of 3.14159, blah, 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 on and on and on. It doesn't repeat, it doesn't terminate. We cannot write it as a fraction. Let's go on to our next set of definitions. A set is just a collection of objects. So you could have a set of DVDs. You could have a set of rocks. In our class, of course, we'll be talking mostly about sets of numbers or values, but a set can be any collection of objects. What we call the members of a set, we use the word elements. So an individual item in a set is an element of that set. If a set doesn't have anything in it, that is, it's the set with no elements, we call it the empty set. Now, how do you express the empty set? We're going to use set notation, brackets, for our sets. And so if I do these two brackets with nothing in there, it's an empty set. The other way that we notate the empty set is a 0 with a slash through it. That's not 0. As soon as you cross it out, that's the empty set. I will advise you, if you're in the habit of writing your zeros like this with them crossed through, you're going to want to break that habit because 0 and empty set are two very different things. For example 1, I want to talk about the number line. How do you put numbers on a number line? Number lines, typically we'll center them at 0, but they don't have to be. But we will put positive numbers and go larger to the right and smaller to the left. So on this one, I'll label some values, and 8 would go right there. When you're graphing a single value onto a number line, we just put a single dot or point on the number line in that location. Similarly for -8, if 0's in the middle and I have positives to the left, -8 will be to the right. And again, if I'm graphing a single value on a number line, I need a point on the number line at that location. Let's talk a little more about this idea of +8, -8. For our next definition, I have the idea of the natural numbers. What is a natural number? Some people call the natural numbers the counting numbers. It's the set of the numbers 1, 2, 3, 4, and on and on. The reason why I have students think of it as the counting numbers is if you're going to start counting a collection of items, you start with the number 1 when you count them up. If we were to graph the set of the natural numbers on a number line, we would put a dot at every counting number. That is, we would start at 1, 2, 3, and we would keep going to the right. Notice that I don't want to color in the number line between the values 1, 2, and 3 because I don't want the numbers between 1, 2, and 3. I just want the values 1, 2, and 3. Now, whole numbers, that's the same thing as the natural numbers, except we're going to add the element 0 to the set. That is, now we have the set that starts at 0, 1, 2, 3, and on and on. If we were to graph these on a number line, it would look very similar to the natural numbers, except now I would put a dot at 0 to include that as well. Let's talk about integers. Integers are the whole numbers together with the opposites of the natural numbers. Well, what do we mean by opposites? We mean negative, or the opposite side of 0 on the number line. So on a number line, our integers would be the natural numbers, 1, 2, 3, 4, and so on to the right, 0, and the opposites of our natural numbers. So the opposite of 1 would be -1, opposite of 2, -2, and so on to the left. So those are our integers on a number line. Let's look at example 2. What are the opposites of the given numbers? If I put 0 in the middle of this number line here, then 6 might land somewhere over here to the right. The opposite of 6 then would be the mirror image of 6 on the other side of the number line. In other words, instead of going 6 units to the right, I go 6 units to the left to get to -6. So the opposite of +6 is -6. Let's look at -9. Again, if 0 is in the middle, -9 might land somewhere over here. The opposite of -9 is the value on the opposite end of the number line from -9, which in this case would be +9. That is, instead of going 9 units to the left to get to -9, we're going 9 units to the right to get to +9. The opposite of -9 is +9. I'm going to leave 3 and -10 for you to work on, but I really want you to understand that the opposite of a positive is a negative, and the opposite of a negative is a positive. Now let's talk about the language of inequalities. If the number A is greater than the number B, we write it like this: A is greater than B. That's our inequality symbol that shows that A is bigger, larger, greater than the value of B. If instead the number A is less than the number B, we would write A is less than B. And that's our inequality notation to show that A is a value that is smaller or less than the value of B. Some like to remember this as an alligator mouth, and that the alligator always wants to eat the larger number. If that helps you, use it. In example 2, we're going to write the appropriate symbol, either the less than symbol or the greater than symbol between our values. In our first one, we have 8 and 3. 8 is a larger number than 3, so the appropriate symbol would look like this, with the open side facing the 8. 8 is greater than 3. Let's skip over to 7 and 10. 7 is smaller than 10, so the inequality symbol will kind of point to 7 and open to 10. And we read that as 7 is less than 10. Let's also look at -9 and +7. I'll draw a number line here for us to look at. With 0 in the middle, we could sketch 7 somewhere over here to the right, and then -9 might be somewhere like this over to the left. Since -9 is to the left of 7, -9 is less than 7. So we would write this as an inequality as -9 is less than 7. Last, let's look at -13 and -11. On the number line, -13, let's sketch it over here. Think about where -11 would be in relation to -13. With 0 in the middle and counting to the left, -11 might be somewhere right there. -13 is on the left side of -11. That is, -13 is smaller than or less than -11. So the correct inequality looks like this, where negative 13 is less than negative 11. I'll leave these other 4 for you to work on your own. Now let's talk about absolute value. The absolute value of a number a, which we write a with these bars on either side of it, is the distance between the value a and 0 on the number line. It's asking the question, how far away from 0 is a? Something to keep in mind that's really important is that distance cannot be negative. You would never say that I live negative 2 miles from school. That doesn't make any sense, right? We would say I live 2 miles from school, regardless of the direction. So distance is always a positive. In other words, absolute value as a distance is always positive. So let's do some examples. The absolute value of 10 is the distance from 10 to 0. Well, if 10 is over there, how far away from 0 is 10? How many units from 0 is 10? This is the distance of 10. We'd have to go 10 units to the right to get from 0 to 10. The absolute value of 10 is 10. Now, let's talk about negative 8. Negative 8 might be somewhere like that on the number line. How far away from 0 is negative 8? How far would you have to walk, say, from negative 8 to 0 or 0 to negative 8? That's a distance of 8 units between those two numbers. So the absolute value of negative 8 is positive 8. I'll leave these other 2 for you to work on, but what I really want you to notice here is that the absolute value is always the positive version of what's inside the absolute value bars. So a negative becomes positive, positives stay positive. And that's the end of this first section.